It is Wednesday, it is day 3, and unfortunately it's the last day of our Continental Industrial Summit. But yes. But especially for you, we have something in stock for you. This is a very special program, and we start with a Science Slam today. So, what is a Science Slam? If you don't have an idea, you ask Wikipedia, and Wikipedia says, a Science Slam is a scientific talk where scientists present their own scientific research work in a given time frame, usually 10 minutes.
So they are going to get you from there.
In front of a non-expert audience.
So they told me that they had only one hair inside.
Okay.
Lizette said they are going to get one more.
The focus lies on teaching current science to a diverse audience in an entertaining way. The presentation is judged by the audience. So now you will play a very, very important part because you are the jury today. We have 2 slammers here on stage, and they will battle about the topics artificial intelligence and machine learning. And at the end of the battle, you will decide who was more convincing. So, I hope you're ready.
Okay.
Woo! Woo! Yeah. Ah, okay. You're ready. Okay, I see. So, ladies and gentlemen, we start with the first Science Slammer. He's a PhD student at Department of Computer Science at Friedrich Alexander University Erlangen-Nürnberg. And the title of his talk is Machine Learning and Why That May Be Spookier Than It Sounds. So now, ladies and gentlemen, 10 minutes for him, and after that, 10 minutes for the other guy. I will tell more about the other guy later. It is very important that you stay now for 20 minutes, so at the end we will have, hopefully, a fair result, yeah? So, ladies and gentlemen, now give it up and put your hands together for Jonas Betzendahl.
Hi, everybody. If I could get my slides, please, that would be fantastic. I kind of need those. Click. Ah, there we go.
It's not voice enabled yet.
Hello. Welcome, everybody, to the Continental stand of the Hannover Messe. I'm here to tell you about machine learning and why that may be spookier than it sounds. But first, what about me? Who am I? Why am I speaking about this? So I studied cognitive informatics and intelligent systems in Bielefeld University, and I'm now doing a PhD in a related field. So the first bit to get you interacting a bit and to get you invested in the topic, maybe throw in, if somebody like me gets invited to a party, what's a typical small talk question that we always get asked? Just,
can you fix my computer?
Can you fix my computer? Well, I can't, I'm sorry. It's messed up, I can't do that. That's not my research topic, but, but at least one person shouted. But the thing is, of course, that was a trick question because people like me don't get invited to parties. But if I catch somebody at the coffee stand or something, it's usually the same question. How long until the killer robot apocalypse? And for years, my answer has always been the same to that. Well, as long as Amazon still does the following. Oh, Mr. Betzendahl, I see you just recently purchased a wallet. Can we maybe interest you in more wallets? I'm not at all worried about killer robots taking over the world tomorrow. I'm just not. Okay, but that used to be how I started my slams, but I don't know. I learned some new things, and we got to talk. I'm not here to dismiss machine learning, not at all. It's a tremendous possibility, and it's a field that can be very, very useful for industry, for academia, for civil society, in all sorts of ways. Really, I'm not here to do that. But there's some things we need to talk about, and that the public needs to know about, or otherwise there might be trouble on the horizon. Okay, First of all, you need to know how machine learning works. So I'm going to explain a little bit. You're supposed to learn something. It is a science slam. I'm very sorry. It'll be over quick, and you can write it in your CV. Okay, so imagine you're a computer science researcher in the 60s, and you get given the task, make the machine think. What would you do? How would you do that? Well, they say imitation is the highest form of flattery, so what the researchers ended up doing is that they looked in the human brain, the most interesting thing we found in the universe so far, and they just sort of tried to rebuild that in a computer. Our brain is fundamentally made of neurons. That is a single brain cell, and that is connected to a lot of other neurons. In informatics, we call that a perceptron, or an artificial neuron. And the thing is, it gets signals into it, and there comes a signal out of it at the end again. There can be multiple signals that go in, and usually only one signal goes out, but it can go to multiple cells. And the magic that happens here, don't worry, this is the most complicated slide in the whole talk. But the magic that happens here, and I need you to understand that for a second, is that from all the input signals, they're not all worth the same. There's a given weight to each of them. So maybe the whole neuron fires, so sends off an energy impulse, only if the first input works, or if the first doesn't work, but the second and third two together. So the magic, really, the learning process is in the weights, in the input, how important each input is for that neuron. Okay, so now we have a rough understanding of how one neuron works. How do many of them work? Well, we connect a bunch of them usually into something that is called an artificial neural network. And then we have a bunch of them. We have these so-called layers, and we connect them to the next layer incompletely, and we connect every of the second layer to the third layer, and so on. And what we do then is that we put like a picture of a panda in the input field and say, this is a panda in the output. And we hope that we follow certain rules to update the weights, and we hope that the neural network learns. And it works stupidly well. Nobody has really any idea why it works so well, but it does. And there's one rule, and I want you to learn this rule. If you learn nothing of this talk, I want you to learn this. There's one rule. How do we determine the weights between each of these cells? There's one rule. It's called fire together, wire together. If we know that we want a panda here in the output layer, then we wire together those that fire together with, this is a panda. So, you know, this is the one rule. If you learn this, and if you can remember it tomorrow, you can write it down in your CV that you're now an artificial intelligence expert. You can quote me in your CV, that's fine. I'll sign off on it. So we'll just practice it a little bit so that I know you've known. I say fire together, you say wire together. Fire together.
Wire together.
Wire together.
Very good, you're all experts now. Wonderful. But there's a bunch of stuff where machine learning still can go wrong. For example, here's a popular example. This is Siri, and Siri was asked in this example, okay Siri, what's the cost of a train ticket from Sydney to Brisbane? And the answer Siri gave is about 28.8 quadrillion kilometer US dollars squared. And okay, how did that happen? That is obviously not the real solution. And what Siri did is that it took the production budget from the movie The Train, multiplied it by the total box office receipts, that's why there's a dollar squared in there, and then multiplied that by the distance from the actual Sydney to the actual Brisbane. There's a problem here. It recognized something entirely different than what you or I would recognize in the sentence. And the thing is, we can't really tell why it recognized this difference. Neural networks only give you answers, not always reasons why that is the answers. They can give you good answers, and sometimes that's enough, but they don't give you reasons. Okay, next thing, also very famous research example. The neural network that's trained here is about 60% certain that the left picture is a panda. Yeah, about 60%. Then we only put a little bit of noise over it. A little bit. You probably don't see it on the screen. Can you tell the difference between the left and the right picture? You can't, but the neural network can. It only has the information of the very exact pixels. And so now, with only this little bit of noise, this neural network is certainly probably 100% sure that this is in fact a gibbon. And it's obviously not. So what we learn from that is that we only have to mess a little bit with the output sometimes and get entirely different results. So in conclusion, how do neural networks work? Oh, well, it's a bit of, well, there's unnecessary data, untrustworthy data that goes into it, and then we do some, and some of, you remember, and then we get infallible results. So, of course, we don't.
Well, good.
What you need to take away from this is that a neural network is only ever as good as the data you put into it. It's really important to give good data to your machine learning, or otherwise it won't work. Okay, there's also some practical problems where there's still problems. For example, here's a survey that was done on humans, whether or not a car should, a self-driving car, if all of the brakes fail and all of the emergency procedures fail, who should we hit if we have the choice? There's this left here says, this left chart gives you the example. So, for example, it should always avoid strollers. I can understand that. But then there's a pregnant lady also very far at the top. But then it goes down, female doctor, female athlete, executive female, male athlete, executive male, and then a large woman. And now suddenly we have very different results, whether or not the woman is pregnant or just voluminous. And I don't want to know how my car will make that judgment. It's really difficult. But, you know, humans have different preferences, and we have to adapt to that in some way. Okay, but here's the one thing that I actually wanted to talk about, adversarial objects. If you learn nothing else, fire together, wire together. But if you learn two things, learn this. The thing is, there's objects in digital space that look very mundane to you and me, but look very, very different for a computer. For example, take this little picture here. Again, maybe audience participation. What do you say that picture shows? Maybe you. A cat. You're absolutely right. But according to Google's image processor, it actually shows guacamole. You can't see that here. The thing is, there's a technique where I can take any picture and make it look like anything else as long as I have access to what is called a classifier. So even the best classifier in the world, even Google's classifier can be fooled with this technique. Usually, it's very easy to correct. So if you rotate the cat a bit, Google also thinks it's a cat again. So that is very particular. But the research result I wanted to present to all of you as a sort of a goodbye message is that this turtle right here is viewed from all angles, and no matter whether it's in an aquarium or on a road, and whether you hold it upright or like slanted or whatever you do with this turtle is always qualified by Google's machine learning algorithm as a rifle. And you wouldn't want to buy this and bring it home as a souvenir from your trip, because what happens at the airport when you're caught with a rifle turtle? So it is very important that if you're designing some machine learning systems for your own businesses, it's important that you have to keep in mind how would anybody exploit those, how can they be attacked, and don't just think, oh well, we'll do machine learning, that's just it. If you wouldn't give the task to a very resilient, very trustworthy baby that could maybe make some mistakes sometimes, maybe consider if there's other ways than machine learning. That's basically all of that. Here you have a little bit more of the turtle. The red bars are classified as rifle. The green one, I think there is one, yes, there's classified as a turtle, but on the black one there's something like a pistol or something, but in almost all things it's qualified as a rifle. That is dangerous, and you need to take that into account if you bring it in your own businesses. Thank you for listening. You've been wonderful. Mwah.
Thank you very much,
Sure.
Jonas. That was our first speech. Please keep that in mind, because at the end you have to decide who was more convincing. And maybe before we start with the next one, you're allowed to come a little bit closer, yeah? Because maybe at the end we want to do some stage diving, yeah? And then we need you. So just come a little bit closer to the crimper, so it is better for our speakers here on stage to feel the love and the passion you have. So, ladies and gentlemen, Jonas was our first speaker, and if we have a first speaker, then of course we have a second speaker. And I'm looking forward to ask on stage a PhD student and at Institute of Machine Learning at Johannes Kepler University Linz. The title of his talk is Machine Learning to Love. And now give him some love, ladies and gentlemen. Put your hands together for Tom Untertina.
All right. Hi, everyone. So nice of you to come out here. So, who of you has ever tried online dating? That's way fewer people than I expected. Then again, this is not my usual crowd. Okay, so just, so you know me, I'm a computer science researcher. I don't particularly like people. I don't like talking with them. I don't like meeting them. I don't like being bothered by them. If I can sit in front of a computer and meet girls, that's exactly my thing. So I obviously did try out online dating. Okay, so right, so you go to the site, you log in, you register, you put on a profile, and actually after 4 minutes, a girl wrote me. The girl's name was Anna, and Anna was a really, really hot girl. Like, like beautiful eyes, intelligent profile, whole thing. And she was writing to me, so that's pretty cool. Hi there. How are you doing, sweetheart? So this is awkward. I've never done this before. Hi, Anna. I'm Tom. I'm a computer scientist. Oh, wow. Oh, wow. That sounds interesting, honey. Why don't you tell me more about that? So this is weird. Like, this girl, she's beautiful. She cares what I do. I better not fuck this up. Anna, I'm a scientist. I'm researching artificial intelligence. I'm trying to teach computers how to think. Oh, wow, honey, that sounds so interesting. Please tell me more about this. So this is really amazing. Like, this girl actually cares what I do. I've never had this before. Like, that girl, me, totally out of my league. Well, Anna, I'm researching neural networks, and they're parameterized nonlinear transformations of the input data to optimize a loss function on a given set of samples to minimize the generalization error runs in future data. That's got to be impressive, right? Oh, wow. Oh, that is so interesting, honey. You know what?
Oh, okay.
Why don't you give me your credit card number, and then we can go have a private chat. This was kind of awkward. It turns out my really first online dating experience was with a chat robot that was only after my credit card. Did that happen to any of you? Like, there's 2 people in the room. Did those 2 people also meet chatbots, or is that just my luck? No. He shakes no, so no. Of course, I'm the only one. Awesome. So that sucks. That sucks for 2 reasons. First of all, Anna was really hot. I would have loved to meet someone like Anna. I'm still looking, by the way. Secondly, I really love talking about my research. So it's really great that all of you are here today, because I'm Thomas, I'm a computer scientist, and I do research on neural networks. And now I'm going to tell you a little bit about that. And I'm going to stick with online dating just to sort of explain how neural networks work and what they actually do and what all this AI and machine learning thing is about. So okay, none of you have tried online dating, but have some of you actually tried Tinder before or know about Tinder? Awesome, more people than before. Still, most of you don't. So briefly, Tinder is a really simple app on your phone. You log in, you create an account, and then you get shown pictures of other people, and you can decide, well, I like those people or I don't like these people. And if 2 people mutually say, well, we like each other, then a chat window opens up and you can sort of go on a date together. Really simple, really awesome. It's really fun in the beginning because you sit there and you're like, oh, I like this, I don't like this, like la la la. In the end, every time you go to the toilet, you waste 10 hours on Tinder. It's really annoying. So I figured, hey, I can automatize this. I'm a computer scientist. Let's write a program that sort of I teach who I like, who I don't like, and then the program can do all the Tindering for me. So how would I go about this? If normally when you write a computer program, when you're a programmer, you write sort of a sequence of instruction for your computer to do. You tell it, well, execute step 1, execute step 2, execute step 3, and then, I don't know, if the result is more than 100, execute step 4a. Stuff like this, right? A sequence of samples. So writing a sequence of like instructions to determine whether I like the picture of a girl or not, that's really tricky. Mainly because I myself have no idea what I like about a girl or not. It's like I can come up with rules what I like and what I don't like. So you know, this is hard. Luckily, there's this new thing called machine learning, where actually I don't have to come up with a sequence of instructions to program my computer. I can just show the computer examples, tell it, look, this is a girl I like, this is a girl I don't like, and the computer will figure it out itself. It will learn. It's a learning machine, hence the name machine learning. That's the beauty of it. So I decided, okay, let's devise a flirtometon, Flow. So Flow will be a program that will learn what kind of girls I like and then will go on Tinder for me. So I will like program Flow, and Flow will be like, well, look at this girl, she's jogging through the woods, and I say, oh yeah, this like I like sports, this girl looks awesome. Then it will show me another picture, and it will be a girl with a cat, and I don't really like cats, so I will be like, sorry, not my thing. And then there might be another one of like a girl who, I don't know, is on the Christmas market having fun with her friends, and I'm like, yeah, this looks fun, okay, cool. Then there might be a girl that's dancing, and I'm like, computer scientist, we do not dance. So okay, I show Flow what I like, what I dislike, and Flow will learn actually. It will learn patterns that are in common of all the girls I like, and patterns that are in common of all the girls I dislike. And then it will sort of figure out and see what kind of girls I will like in the future. And in fact, then after a while I can go to Flow, and Flow will be like, hey Tom, I found the perfect girl for you. Tom, please hold your breath, because this right here is Waltraud. Now, Waltraud was a little bit taller than me. Waltraud was a little bit broader than me. Waltraud was a little bit beardier than me. So this didn't really match up with what I expected. So I asked Flo, why? And Flo was like, well, you know, Tom, she's a forest ranger. That didn't make sense. I was like, okay, what else? Well, come on, Tom, how have you not figured this out? Waltraud, she actually won the wood chopping world championship last year. Yeah, she looks like it, but that doesn't make sense either. Well, Tom, how have you not figured this out yet? Dude, you like a girl in the forest. You like a girl on the Christmas market. Dude, actually, you're into trees. I'm not into trees. But what's happened here? What's happened here is actually, it's really hard to write a program that learns patterns that are meaningful for humans. If I show a computer program pictures of girls I like, and in the pictures there's always like trees or a forest, it will end up thinking, or it might end up thinking, that my dream girl is actually a Christmas tree. And that's unfortunate, but that's really sort of the stage of research we're at. And Jonas before told you some of the difficulties with this. And when you do machine learning research, really, you're trying to come up with ways to write programs that learn patterns that are meaningful for humans and that are meaningful on future data, and they're not just sort of artifacts of those random few samples that you show it. And you know, after this mishap, I sort of abandoned the whole online dating thing and let Flow just do its own thing. Recently I checked in with it again, and Flo was really excited once more and was like, Tom, you're not going to believe this. I met a girl that is perfect for me. Like, for Flo itself. And he was really, really, really excited. He was, well, you know, Tom, like, this girl is really interested in what I'm doing. And this girl is really eager to meet me. There's just one weird thing. She wants my credit card number before we meet. Yeah, that didn't make sense. So apparently AI is not really at that stage yet. That's it for my talk. Thank you so much for your attention, and have fun here at Hannover. Thank you.
Thank you very much, Tom. And now it is time, ladies and gentlemen. Don't go away. I need both on stage. Jonas and Tom, please come on stage, because now it is time for the decision. And it's a decision, ladies and gentlemen. It's a huge decision. So now it's your turn. Who was more convincing, yeah? We start with Jonas, so you have you have to clap your hands. And wait. But I have to tell you who is. It is Jonas. So now, ladies and gentlemen, it is Tom. Okay, we have a prize for the winner, because but because we know that you both are excellent, we prepared 2 prizes, So we have 2 winners, ladies and gentlemen, and look now what's coming. It's a bag with amazing stuff inside,
Ooh, thank you so much.
This is Christmas, this is Easter, this is your birthday, everything together.
All of it.
Yes. So thank you very much for being here. And the great thing is you stay here, because the next talk in 2 minutes is about artificial intelligence. And we have 2 more experts here on stage. So don't leave, stay with us. In 2 minutes, we continue.
Thank you so much.
Thank you.
Yes.